Welcome. In this video, we're going to go over labor transfers and cost rollup functions within E-Z-MRP to accurately cost parts and assemblies. So in this example, we have a made part that's an electrical box final assembly. And right now it has zero material costs, zero labor costs, and zero burden rate. And so if we look at this electrical box product structure diagram, you can see that it is made of a bunch of materials. It's got screws, hinges, a cam latch. It even has some sheet metal parts such as the front cover and the cake box on the back side that are made of raw materials such as this 18 gauge wipe coat steel. So not only is there labor associated with making the electrical box, there's actually labor associated with making these sheet metal parts as well. So in this lesson, we're going to go over how to calculate the labor costs automatically within E-Z-MRP using the data that we've entered into the routings and the work centers. All right, so the first step is to do a labor transfer. So you'll exit to the main menu and then go to capacity planning. And then it says here under other functions, transfer labor costs. And it'll bring you to this screen and you just want to press transfer costs. Ready to transfer costs? Okay to continue? Okay. So the cost transfer has been complete. Now when we go to the part master, to that electrical box assembly, we have a labor and a burden cost associated with this part. But we don't yet have material. So in a little bit, I'll go over how to get that. But I just want to go into how this cost is calculated. So there's a button down here called Routings, and if we go there, it'll bring us to where this part is routed through. So it is routed through AS001, and there's only one operation, and that operation is to assemble the electrical box and check overall dimensions. And that runtime takes about 10.2 minutes per piece. So we have a time element associated with this part. So it takes 10.2 minutes per piece to make, but there's also a rate. So let's look up the rate of this AS001. Actually, I'm just going to record this 10.2 minutes. So that's 10.2 minutes. And that equals roughly 10.2 divided by 60, 0.17 hours. Okay, so going back to E-Z-MRP, let's look up the cost or the pay rate of this work center. Exit that, and we'll go to, if you go from the main menu and you go to capacity planning, and then you go to work centers, you can look up the work center here. If you toggle between these arrows, we find that the labor rate is 13.85 per hour. So the pay rate, or maybe just to be consistent here, we'll call this labor rate. Is $13.85 per hour. So if we multiply our labor rate by our time, our hours will cancel, and so we will get a cost. So $13.85 per hour times 0.17 hours. Our hours cancel, and we are left with $2.3545. So let's go back here to our part master. We'll press exit and exit to main menu, bills of material, part master. And lo and behold, we get 2.355. So if you would round this, you would also get 2.355. So that's how the cost roll-up works. And so this is a really powerful function because it doesn't just do this part, it does this part as well. So we have a labor rate associated with the front cover, and we have a labor rate associated with the cake box. So then we have a labor rate for all parts. And if you imagine a manufacturing facility would have possibly hundreds to thousands of parts that they make, and that labor transfer cost will calculate every single labor cost, just like I showed you for this example. So a lot of manual calculations are now you don't need to worry about those because it's automatically done in the MRP software. So it actually kind of goes to show that if you have an error in how long it takes to make a part, you could have wildly different labor costs. And this would affect your ability to be profitable. You might underestimate or overestimate how much a part takes to make. So that's a really neat aspect of this program. So now that we've covered labor costs, we're going to cover the cost roll-up. So we'll exit to the main menu, and now we'll go to bills of material, and then you press cost roll-up. And then press begin cost roll-up. Ready to begin cost roll-up? Okay. So it doesn't take that long. Again, there's not very many parts or assemblies in this E-Z-MRP database. So it doesn't take that long. So now when we go to part master, we have a material cost associated with this. So let's look at how this material cost was calculated. So we'll go back here. And so each one of these has a labor cost and a material cost. So we have a labor cost here. And a material cost. And This component here, the cake box, has a labor cost and a material cost. We also have a labor cost and a material cost here. So far we've calculated the labor costs of each and every single one of these. So let's look at this part here. So the raw material, the 18 gauge wipe coat steel, has a material cost of $0.033 per square inch. And it has no labor cost associated with it because it's just a raw material. If we go to the cake box, which is made from this material, it has a material cost and a labor cost. So let's look at how this material cost for the cake box was calculated. So to do that, we have to go to the product structure of this part. And here we find that the quantity per assemblies of this component here is 576. So we go back here, just going to calculate our labor costs in this section right here. So the material was equal, the material cost was equal to $0.033 per square inch. And we used the amount of material was 576 square inches. So if we multiply this to get our cost equals 576 square inches times 0.33 per square inch. And so we would get 576 times 0.033 equal to 19.008. And so dollars. So if we look here, exit this, exit to, we'll go to the part master again. We get 1875. So close, but it's not the same. It should be exactly the same. So why is it different? Well, let's look at this part here. I think there's a rounding error. Yes, so it's actually not 0.033, it's 0.03255. So let's go back and calculate that now. So that's 0.25583. So, and that's going to be used here as well. 0.0325583 times 576. So now I'm getting 18.75. And so that actually kind of goes to show how much rounding affects the cost of the part. And so it's really good to keep as many decimal places as possible. So that is how the cost of material cost is calculated. But also included in the material cost is the labor. So if we go back here, the labor is actually 0, so that doesn't actually add any cost to the material here. But for the electrical box, the material and the labor of the previous function is included in the material cost of this part. I'll show you what I mean. So both of these costs go into sort of a total cost. And then that goes into the material cost. And so in this example, there wasn't any labor associated with this raw material, so this is actually 0. But there is labor for making the cake box, so that whole thing gets rolled up into a total cost. And then becomes the material cost of the electrical box. And that would occur for this component, this component, this component, this component, and this component. It's just when you're using raw materials, there is no labor associated with making those because you just buy them. But you know, when you bought those parts, there must be some sort of labor at the factory where these are made, but you just take it as a material cost when you buy it. So it's sort of a similar concept when you're making this, that the labor of the previous part turns into the total cost, turns into the material cost of the final assembly. So it's just a way of accounting for all of the costs and showing the labor cost of just the electrical box. So if we look at that, the material cost is almost $37. The labor cost isn't the labor. This labor cost is just for assembling the electrical box. It is not the labor cost of making all of the components that go into the electrical box. So finally, all of this is added together and we get a total cost of $39.47. So that is really, really, really quite powerful because now I know that I need to sell this component for over this amount of money. Otherwise, I'll probably go out of business. Most definitely. You can't turn a profit if you're not selling the component for a reasonable price. Okay, so that is that kind of concludes this lesson. I just want to stress one more thing, and I'll write it in red here. You have to do your labor costs or your labor transfer and then the cost roll up. If you don't follow this, you actually won't consider the labor cost of this component, and so it won't be included in the material cost of this component, and so you won't get an accurate number or an accurate cost of the final assembly. So always, always, always make sure to do your labor transfer and then your cost roll up. So if you have any comments, leave them in the comment section below. And also, if you have any questions, you can leave them in the comment section below. All right, thank you for watching, and we'll see you in the next video.